In the vast expanse of our solar system, a cosmic dance unfolds, with planets twirling around the sun in a mesmerizing ballet of celestial bodies. Amongst these celestial bodies, Mercury stands out as the smallest and closest to the sun. Its surface is a rocky, cratered landscape, reminiscent of our moon. One might assume that its proximity to the sun would render it the hottest planet, given the intense solar radiation it receives. However, the cosmos often defies intuition, and in this case, Venus, the second planet from the Sun, claims the title of the hottest planet. Venus, often called Earth's twin due to its similar size and composition, harbors an environment that is anything but twin-like. This seemingly paradoxical situation arises from the unique characteristics of both planets. While Mercury is a barren world with no atmosphere to speak of, Venus is shrouded in a thick, toxic atmosphere. While Mercury endures scorching temperatures during the day, reaching up to a staggering 840 degrees Fahrenheit, its surface is bombarded by the sun's relentless rays. Its nights are a frigid affair, with temperatures plummeting to -275 degrees Fahrenheit. This drastic temperature swing is due to the lack of an atmosphere to retain heat. This stark contrast is a testament to the absence of a substantial atmosphere on Mercury. Without an atmospheric blanket, the heat escapes into space as soon as the sun sets. Venus, on the other hand, boasts a remarkably different environment. Its thick, swirling clouds of sulfuric acid create a dense, oppressive atmosphere. Its thick atmosphere, composed primarily of carbon dioxide, acts as a colossal blanket, trapping heat and creating a runaway greenhouse effect. This effect is so powerful that it keeps the planet's surface at a constant searing temperature. Consequently, Venus experiences a consistently scorching temperature of 863 degrees Fahrenheit, both day and night. This unyielding heat makes Venus the hottest planet in our solar system, a true testament to the power of atmospheric dynamics. The planet's proximity to the sun means it receives about 7 times more solar energy than Earth. This intense heat is enough to melt lead, and it has a profound effect on the planet's surface. The scorching temperatures cause the rocks and minerals to expand. Over billions of years, this has created a network of cracks and fissures. These temperature fluctuations are extreme, leading to significant geological changes. These features, known as scarps, crisscross the planet's surface, some stretching for hundreds of miles. As the sun sets on Mercury, the planet's lack of atmosphere becomes readily apparent. Without an atmosphere, there is nothing to retain the heat. With no insulating layer to trap heat, the surface rapidly radiates its heat back into space. The temperature drop is dramatic and swift. Temperatures plummet to a frigid -275 degrees Fahrenheit, colder than the coldest temperatures ever recorded on Earth. This stark contrast between day and night temperatures makes Mercury a planet of extremes, where survival would be impossible for any known life form. In contrast to Mercury's harsh and unforgiving environment, Venus possesses an atmosphere that is both dense and dynamic. Unlike Mercury, which has almost no atmosphere to speak of, Venus is shrouded in a thick veil of clouds that are constantly in motion. This thick atmosphere, composed primarily of carbon dioxide, acts as a colossal blanket, trapping heat from the sun and creating a phenomenon known as the greenhouse effect. The clouds are so dense that they reflect about 75% of the sunlight that hits them, making Venus the brightest planet in our night sky. The greenhouse effect is a natural process that occurs when certain gases in a planet's atmosphere trap heat from the sun. This process is essential for maintaining temperatures that can support life, as it keeps the planet warm enough to sustain liquid water. These gases allow sunlight to pass through but prevent some of the heat from escaping back into space. On Earth, this effect is balanced and helps to keep our climate stable. This trapped heat warms the planet's surface, making it warmer than it would be otherwise. On Venus, this is amplified to another level. The planet's thick atmosphere traps so much heat that the surface temperature becomes incredibly high. The thick atmosphere, combined with the planet's slow rotation, creates a runaway greenhouse effect that has resulted in a surface temperature hot enough to melt lead. This makes Venus the hottest planet in our solar system, even hotter than Mercury, despite being further from the sun. Another factor that contributes to Venus's extreme heat is its high albedo. Albedo is a measure of how much light a celestial body reflects. A perfectly reflective surface has an albedo of 1, while a perfectly absorbing surface has an albedo of 0. Venus has an albedo of 0.9, meaning that it reflects 90% of the sunlight that strikes it. This high albedo is due to the thick clouds of sulfuric acid that blanket the planet. These clouds act like a mirror, reflecting most of the sunlight back into space. While Venus's high albedo might seem like it would make the planet cooler, it actually contributes to its extreme heat. The heat from the reflected sunlight is absorbed by the planet's atmosphere, further contributing to the greenhouse effect. A tiny world. Mercury, the smallest planet in our solar system, stands in stark contrast to Venus. With a diameter of only 3,032 miles, it is slightly larger than our Moon. Despite its diminutive size, Mercury is a fascinating planet. Its small size has had a profound impact on its evolution. Its weak gravity has made it difficult for the planet to hold on to any atmosphere. As a result, Mercury has a very thin atmosphere known as an exosphere, which is constantly being stripped away by the solar wind. This lack of atmosphere has also contributed to Mercury's extreme temperatures. Without an insulating layer to trap heat, the planet's surface experiences dramatic temperature swings between day and night. Mercury's surface is a testament to its long and violent history. Billions of years of bombardment by asteroids and comets have left their mark on the planet's surface, creating a landscape that is heavily cratered and scarred. One of the most prominent features on Mercury's surface is the Caloris Basin, a massive impact crater that spans over 900 miles in diameter. This colossal crater is thought to have been formed by the impact of an asteroid or comet early in the solar system's history. The impact that created the Caloris Basin was so powerful that it sent shockwaves rippling through the planet, creating a region of chaotic terrain on the opposite side of Mercury. This region, known as the antipodal terrain, is characterized by jumbled hills and valleys. Beneath Mercury's heavily cratered surface lies a surprisingly large metallic core. This core, which makes up about 85% of the planet's radius, is thought to be composed primarily of iron and nickel. The presence of such a large core has led scientists to believe that Mercury may have once been a much larger planet. Some theories suggest that the planet may have been stripped of its outer layers by a giant impact early in the solar system's history. Despite its metallic composition, Mercury's core is not molten. However, it is thought to be partially liquid, with a solid inner core surrounded by a liquid outer core. Our understanding of Mercury has been greatly enhanced by the Messenger spacecraft, which orbited the planet from 2011 to 2015. Messenger's observations revealed a wealth of information about Mercury's surface, composition, and magnetic field. One of Messenger's most surprising discoveries was the presence of water ice in permanently shadowed craters at Mercury's poles. This ice is thought to have been delivered to the planet by comets or asteroids. Messenger also provided valuable insights into Mercury's magnetic field. The spacecraft's observations showed that Mercury's magnetic field is offset from the planet's center, a finding that has puzzled scientists. The data collected by Messenger continues to be analyzed by scientists, providing new insights into this enigmatic planet.